Hello everyone, welcome back to Calculus BC. We're in lesson number 39 where we're talking about polar equations, and in this video we're going to talk about the area and how to find area between two polar equations. And there are two situations that we are going to encounter. One is going to be how to find the area inside one function but outside the other, as you guys can see in example number 6. And then there will be a problem where you will have to find the area that's that's a common interior to both the functions. So we're going to start with actually example number 6, where it says find the area of the region lying inside the circle r equals 3 cosine of theta and outside the cardioid of r equals 1 plus cosine of theta. So in this example, we have something on the inside, but on the outside of this cardioid. So this is the formula that we're going to use, and I just want to say really quickly that from the previous video that we just did, you guys can see that the area of a polar equation is 1/2 a and b, and then it's the function quantity squared d theta. So in this particular example, when we're looking at two functions, then we're going to look at, especially if it's outside, this is always going to be your outer function, and this is always going to be your inner function. So it's not like right minus left or up minus down or whatever it is. It's always the outer function and then the inner function. So the best way for me to explain this to you guys is to, first of all, graph these two functions so we can kind of see what's going on in our actual picture. So r equals 3 cosine of theta. So we know that since this is the case, we have r equals 3 cosine of theta. We're going to go ahead and go to 1, 2, 3, like so. And remember, because it's cosine, it's going to be symmetric to the cosine graph. And since it's a circle, it's going to look something like this. And you guys don't have to be perfect with your graphs at all. You just want an idea. You want to be able to sketch something that you guys can kind of see what's going on with this. So I'm going to change the color here now. It's going to be on the outside of the cardioid. So it actually tells you what that is. So remember that, again, if we look at this problem, we know that the 1 plus 1 is going to be 2. We know that that's going to be our big part. And then it's going to be 1 and 1. And then we're going to draw ourselves a picture. And I wish that this had been a little bit bigger, but it is okay with our color scheme here. So knowing what the graph looks like is actually really important, right? Really important. And so what we're going to now do is we want to find the area that lies inside of the circle, inside the blue, but outside the cardioid. So you guys can clearly see it's going to be this little guy right here. So we want this area. So there's a couple of things that we can do in order to solve this problem. And so I'm going to go with what I think is probably the easiest way for me to explain it to you guys. But the first thing we got to do is we got to figure out these intersection points. So we need to know what the intersection point is right here and the intersection point right here. So set them equal to each other. 3 cosine of theta is equal to 1 plus cosine of theta. So we're going to go ahead and subtract. We're going to get 2 cosine of theta is equal to 1. Cosine of theta is going to be equal to 1 over 2. So cosine of theta equals 1/2. Well, that's going to be in the pi over 3 family and the 5 pi over 3 family. This is actually kind of helpful because you guys can see that in the first quadrant here, we're at pi over 3. And then here we're at 5 pi over 3. Now I'm just going to tell you guys really quickly that I'm going to do this problem in 2 different ways, but I'm going to show you guys the shortcut first because I think this is actually the easier way to do this. So if you look at what we're trying to find the area of, if you guys can see that if we just take the top part of our shaded region, if we were to find that, then we really could just double it, right? And that gives us the other part because we're just symmetric to the x-axis. So let's actually look at what we're doing here. So we're starting right here at 0. So the area is going to be equal to, well, I'm going to go ahead and pull out the 1/2. That's just the easiest way to do this. So what we're going to bound it by. So we're going to bound by 0, and we're going to follow the curve like we talked about before. So we're going to follow the curve with the shaded region. So we're going to go from 0 to pi over 3. Just like this. And so we're going to follow the formula that you see right here. So 0 to pi over 3. And then we're going to do the outer curve first, which is going to be the circle. So you guys can see that that's going to be the circle. So we're going to go ahead and do the outer curve, which is 3 cosine of theta, quantity squared, d theta. And then we're going to do minus the integration of, and again, from this one, it's also going to be 0 to pi over 3. So we're going to go integration of 0 to pi over 3. Of our outer curve, our inner curve, which again is going to be the cardioid. 1 plus cosine of theta squared d theta. So this right here gives us the yellow region. It gives us the yellow region. So what I can essentially do now is take this function and then multiply everything by 2, and that's going to give me the actual region here. So that would actually fit this piece right here. So that would actually give us the rest of this thing. So that is one way that we can do this problem. Well, let's look at another way. Another way that we can do the problem without splitting it is the following. We can go ahead and do area is equal to 1/2. What you do not want to do is you do not want to go from 5 pi over 3 all the way to pi over 3, because that's what a lot of people want to do. You could go 5 pi over 3 to 2 pi, and then again from 0 to pi over 3, and that again requires 2 intervals. What you could do, though, is realize that 5 pi over 3, well, what's another way of writing 5 pi over 3? Coterminal angles. So what else could we do for this? So 5 pi over 3 is actually negative pi over 3. So this is actually also really helpful. So if I'm starting right here, if I go negative pi over 3, I'm actually going to go to this direction right here because they're the same thing. So I can go from negative pi over 3 to pi over 3, and that gives me the whole thing, and that way I don't have to worry about the multiplying by 2 part. So that gives me the whole part of this. So from negative pi over 3 all the way to pi over 3. Again, you guys could do 5 pi over 3 to 2 pi, and then 0 to pi over 3, but again, I think that's actually even harder than the rest of these problems. And the rest of it just actually follows in suit here. We can do 3 cosine of theta quantity squared. And actually, ladies and gentlemen, because it's the same thing, since we're bounding it from 0 to pi over 3, we can just go ahead and just save ourselves a little bit more time and just do this. And then that's it. So there's 2 ways I said to do the problem. Again, knowing what the picture looks like, and then knowing the intersection points, and then kind of knowing, the formula. That's really all that we have to do for these problems. And then for both of these problems, when you plug it into your calculator, you're going to get pi. So both these answers are going to be pi. So let's do one more example of this and see if you guys are okay with what's going on. And like I said, whatever method speaks to you is the way you should do the problem. So question number 8 says, find the area of the region outside r equals 3 plus 2 sine of theta, and inside of the equation r equals 2. Well, r equals 2 is the radius equals 2, so that's the best equation that we can get as far as simplicity is concerned. So you just do where everything, the radius is 2. So this is actually a circle as well, where the center is now actually at the pole. And the other one that we want to see here is that this is 5, so 5 in sine. So again, the way I think about this is that 3 plus 2 is 5, so 5 and then sine positive. So we go 1, 2, 3, 4, 5. This a term right here tells us how far on the other curve it is. So this is 3, and this is 1, 2, 3. Since a is greater than b, we know it's not an inner loop, so we know the difference of these two numbers is going to be where it's going to be on the outside, and we just start highlighting. So that's the easiest way to do this. Remember, you guys are not responsible for knowing what the graphs look like. I'm sorry, what they're called, just what they look like. So here's our little graph. And so the question says, find the area of the region outside of what I just wrote in green, but on the inside of the circle. So, like I said here, we want to find this right here. We want to find this area. So first thing we're going to do is we're going to find the intersection points of those two functions. So we're going to set 3 plus 2 sine of theta equal to 2. And then we're going to do 2 sine of theta is equal to -1. And then sine of theta is equal to -1/2. And again, ladies and gentlemen, what's great about these problems that you know that you've got these graphs correctly drawn, because sine of theta is -1/2 and sine is negative in quadrants 3 and 4. So we know that we're going to be looking for the pi over 6 family, we're looking for the 7 pi over 6, and we're looking for the 11 pi over 6. So we know that right here, this is going to be 11 pi over 6. And we know that right here, this is going to be, that's 7 pi over 6, and this is going to be 11 pi over 6. So we actually know what our bounds are, because from here to here, it's 7 pi over 6 to 11 pi over 6, and same thing with this right here. So we just got to follow the formula. So this is the only way that I can see that we can do this that makes more sense. We get the 1/2. We're going to go 7 pi over 6 to 11 pi over 6. We're going to do the outside curve first. The outside curve is going to be the 2. And again, ladies and gentlemen, this is important that it's the outside minus inside, right? It's not top minus bottom or anything like that, like you guys did with Cartesians. So 2, and then remember we square it, and then we can do minus 3 plus 2 sine of theta quantity squared d theta. And That is all that you have to do for the problem. And then when you guys plug it into your graphing calculator, you're going to get 2.196. 2.196. So that is how you do functions when we're looking for the region on the outside and inside. So I showed you guys one where it was pretty straightforward, and then one that actually is symmetric to an axis where you can break it up if you need to. So whatever is the easiest for you guys to do is the way that I want you to do it. So this is it for this video. In the next one, we're going to talk about how to find the area when it's enclosed in a common interior. So I'll see you guys in the next video.